so that we can see what lies ahead for our energy-intensive global society. In the first part, we looked at the way in which steady growth can produce very, very large numbers. Then we saw the way in which steady growth, or rate of consumption of a finite resource, could lead to the very surprisingly early expiration of that resource. We want now to look at some specific resources, and we want to start by looking at world petroleum consumption. Here we have a semi-logarithmic graph of world petroleum consumption prepared by the late Dr. M. King Hubbard. And it shows for the period from 1870 up to 1970. And you can see the line's been approximately straight, average growth rate close to 7% per year. Now, it's logical to ask, well, how much longer could that 7% have continued after 1970? That's answered by the numbers in this table. In the top line, the numbers tell us that in the year 1973, world oil consumption was 20 billion barrels. The total consumption in all of history, including that 20, was 300 billion. The remaining oil reserves, 1,700 billion. Now, those are data. The rest of this table is just calculated out. Assume that the historic 7% growth that we'd seen for 100 years continued steadily in the years following 1973. Now, fortunately, the growth did not continue. Because of the high prices from OPEC, the growth stopped. So we're asking, what if? Suppose the growth had continued. Well, let's look at the year 1981. By 1981, on the 7% curve, the total usage in all of history would add up to 500 billion barrels. The remaining reserves at that point, 1,500 billion. Now note, at that point, the remaining oil reserves would be 3 times the total of everything that had been used in the entire history of the oil industry on this earth. By most measures, you'd say that's an enormous remaining reserve. But what time is it when the remaining reserve is 3 times the total of all that you've used in all of history? And the answer is it's 2 minutes before 12. We've seen for 7% annual growth, the doubling time is 10 years. We go from 1981 to 1991. By 1991, on the 7% curve, the total usage in all of history would add up to 1,000 billion barrels. The remaining oil reserves at that point, another 1,000 billion barrels. Now, at that point, the remaining oil would be equal in quantity to the total of everything that had been used in something like 140 years of the oil industry on this earth. By most measures, you'd say that is still an enormous reserve. But what time is it when the remaining reserve is equal to all that you've used in all of history? And the answer is it's 1 minute before 12. And so we go one more decade to the turn of the century, and we find that's when 7% would finish using up all the oil reserves of the earth. Now, there's something very important to note here. The author of this table added 3 extra years after the end of the petroleum. I want you to understand the meaning of those 3 years. That is the total length of time that 7% growth would continue if you consumed all of the known oil shale on this earth. 3 extra years of 7% annual growth in the rate of consumption of oil. Now let's look at this in a very nice graphical way. Suppose the area of the tiny rectangle in the upper left represents all the oil that we used on this earth before the decade of the 1940s. Then in the 1940s we used this much. That's equal to the total of all that have been used in all of preceding history. In the decade of the 50s we used this much. That's equal to the total of all that have been used in all of preceding history. In the decade of the 60s, we use this much, and again, that's equal to the sum of everything that had been used before. Now, here you see graphically the thing that President Carter told us. If the 7% had continued through the 70s, if it had continued through the 80s, and if it continued through the 90s, here's what we need. But that's all the oil there is. Now, there's a widely held belief in the Congress that if you throw enough money at holes in the ground, oil is sure to come up. Now, there will be discoveries of new oil. There may be major discoveries, but look, we have to discover this much new oil if we would have that 7% growth continue another 10 years. So let me ask you, what do you think is the chance that oil discovered after the close of this tape will be equal in quantity the total of all we've known about in all of history, and then realize if all that new oil could be found, that would be sufficient to let the historic 7% growth rate continue 10 extra years. Now you see interesting representations of this. Here's an interview in Time magazine with one of the most widely quoted oil experts in all of Texas. He's asked, but haven't many of our bigger fields been drilled nearly dry? And he responds, there's still as much oil to be found in the U.S. as has ever been produced. Now let's assume he's right. What time is it? And the answer is it's 1 minute before 12. Now, let's just see what this means in terms, for instance, of food. Let's look at a very interesting definition of modern agriculture. Modern agriculture is the use of land to convert petroleum into food, and we can see the end of the petroleum. Well, in the crisis in the early 1970s, ads such as this appeared. This is from the American Electric Power Company. It was a bit reassuring, sort of saying, now don't worry too much because we're sitting on half of the world's known supply of coal. Now, where did that figure come from? Well, it may have had its origin in this report to the Committee on Interior and Insular Affairs of the United States Senate, because in this report we find this sentence: at current levels of output and recovery, these American coal reserves can be expected to last more than 500 years. Now, there's one of the most dangerous statements in the literature. It's dangerous because it's true, but it isn't the truth that makes it dangerous. The danger lies in the fact that people take the sentence apart. They just say coal will last 500 years, and they forget the caveat with which the sentence started. Now, what were those opening words? At current levels. Now, what does that mean? That means if and only if we maintain zero growth of coal consumption in the United States. So let's look at a few numbers. From the Annual Energy Review 1991, published by the United States Department of Energy, we find this figure for the coal demonstrated reserve base. Also, there is the footnote that about half of the demonstrated reserve base of coal in the United States is estimated to be recoverable. So this figure is half of this figure. So if we want to calculate how long coal could last, we'll calculate it for each of the figures and then say that the answer is probably in between the answers we get from each of the two calculations. Now, that 1991 review also gave these figures for the rate of consumption of coal in 1971 and in 1991. If you put those two together to find the average growth rate of coal consumption in the United States, over that 20-year period, you have 2.86% per year, and we'll come back to that 2.86 in just a moment. And so you might ask, well, how long could a resource last if you had steady growth in the rate of consumption till the last bit of it was used? Well, I'll just show you this equation for the expiration time. I'll tell you it takes first-year college calculus to derive this equation, so it can't be very difficult. You know, I have the feeling there must be dozens of people in this country who have had first-year college calculus. But let me suggest I think this equation is probably the best-kept scientific secret of the century. Now, let me show you why. If you use this equation to calculate the life expectancy of U.S. coal, using the reserve base, or the 1/2 of the reserve base that they estimate might be recovered, for different steady rates of growth, you find if the growth rate is 0, the small estimate would go 236 years, the large estimate would go 473 years, and that's close enough to 500 so that we can say that report to the Congress was correct. But look what we get if we plug in steady growth. President Gerald Ford set goals of coal growth of around 8% per year. If that could be sustained until the coal was gone, coal in this country would last between 37 and 46 years. President Carter cut that goal roughly in half, hoping to reach a goal of 4% growth per year in coal consumption. If that could be continued till the coal was gone, coal would last between 59 and 75 years. Here is that 2.86% per year. The average over the 20 years from 1971 to 1991, if that average growth rate continued, coal would expire between 72 and 94 years. Now, that's within the life expectancy of children born in 1991. The only way we're going to get anywhere near 500 years worth of coal is to have zero growth and to plan to use essentially all of the coal. Now, let's look at the history of coal consumption in the United States. Here, from the work of the late Dr. M. King Hubbard, we have the semi-logarithmic graph of U.S. coal consumption. From the close of the American Civil War to about the year 1910, coal consumption grew steadily, almost 6.7% per year. Then as we switched to liquid petroleum and natural gas, we experienced zero growth of coal production for a period of 60 years. This straight line represents the average growth rate of coal consumption for the period 1971 to 1991. Now, the interesting question to ask is, how long could we continue if we start with the 1991 figure and continued on a 6.7% growth curve? And the answer is coal in this country would run out in 52 years. And so the calculated expiration times and the graph showing the history of coal mining in the United States, these are representations of facts. These are drawn from authoritative sources. I ask you, please keep these facts in mind. In the 1970s, there was great national concern about energy, but the concern disappeared in the 1980s. The concerns about energy in the 1970s prompted experts, journalists, and scientists to assure the American people that there was no reason for concern. We look now at some of these assurances from the 1970s so that we can see what we can expect when the energy crisis returns. Here is the director of the Energy Division of the Oak Ridge National Laboratories telling us how expensive it is to import oil, telling us we must have big increases in our consumption of coal, and telling us that under these conditions, he estimates America's coal reserves are so huge they could last a minimum of 300 years, probably a maximum of 1,000 years. You've just seen the facts. Now you see what an expert tells us, and what can you conclude? There was a 3-hour television special on CBS on energy. The reporter showed the enormous efforts being made to achieve rapid growth of coal consumption in the United States. In summary, the reporter said, by the lowest estimate, we have enough coal for 200 years, by the highest, enough for more than 1,000 years. You've just seen the facts. Now you see what a journalist tells us after careful study. And what can you conclude? From the Journal of Chemical Education, we have an article written by the staff of that journal. And in there we read that our proved coal reserves are enormous, and they give a figure. These could satisfy present U.S. energy needs for nearly 1,000 years. Well, let's do long division. You take the coal they say is there, divide by what was then the current rate of consumption, you get 180 years. But they didn't say current rate of consumption, they said present U.S. energy needs. Well, coal today supplies about 1/5, about 20% of the energy we use in this country. So if you'd like to calculate how long this quantity of coal could satisfy present U.S. energy needs, you have to multiply this denominator by 5. When you do that, you get 36 years. They said nearly 1,000 years. Newsweek magazine, in a cover story on energy, said at present rates of consumption, we have enough coal for 666.5 years. Now, the 0.5 means it'll run out in July instead of